Hello all, welcome to Tech with Sass. In this video, we will talk about Saga pattern in microservices. So let us start with the agenda for this video. In this video, we will start first with distributed transactions and its challenges. Then we will understand about two-phase commit, like how it is done, and then what are the problems with two-phase commit. After these things are clear to us, then we'll able to focus on the Saga pattern. We'll also focus on how we can implement Saga pattern because there are two ways by which we can implement a Saga pattern. Like first is the choreography Saga pattern, then second is the orchestration Saga pattern. So this is the agenda for this video. So because I will not come to Saga pattern directly because it need some context to understand, and the context will be set by the part one of the video. And in the part one, like if you are clear all with these concepts in the part one, then you can directly go to the my second video. Otherwise, I would recommend that first you complete this video, then go to the second part of the video of the series, like where I will discuss about the saga pattern, right? So let us understand and learn about the saga pattern and start with this. Before microservices based distributed architecture came into existence, or in other words, it was widely adopted by the industry. Systems used to be very simpler. Like, for example, if you had to make an application that is for the Book My Holiday application, right? So you had to first create the application UI that is going to interact with a backend application, like very like one application that is housing all the functionalities at one place. So whenever Book My Holiday application UI want to interact with any functionality, it is like a one-stop solution for that. And this backend application will be interacting with only one database. So this ensures that we are able to maintain the properties of ACID very easily, right? So if you don't know about these properties, these are like really important in terms of keeping our database consistent across various transactions. So I will make a detailed video on that, but for now, just to understand, A means the atomicity. So whatever transactions we are performing in our application, that should be completed in totality, or it should not be done at all. Second property is the consistency. So whenever database is changing its state from one to another state, it should be consistent. There should not be any dirty reads or writes happening in database. Third is the isolation, I. So it means that because in our application we're always having transactions happening in parallel, right? So those transactions should not interfere with each other. Also, they should behave like they're happening in a sequential manner. And third is the durability. So it means that whenever we are doing any commits to the database, that should remain there forever, irrespective of any failure at like maybe a power failure or any other issues happening. So these properties are really important in terms of keeping our data consistent in database. So this system which you see here is quite simple because we have only one point of contact with database, and that application is controlling all the functionalities by a function call. So we can easily maintain these properties and we can make sure that we are consistent. But the issue comes when we use the transactions like in a microservices based application where apps are distributed, right? So suppose a SIM application you build like that Book My Holiday application, you have built in a microservices based architecture, which is like a distributed architecture. And in that, you have like a business scenario where all the functionalities like hotel, flight, or call interval should happen in one go, right? If any of the transaction is not happening or there is some failure, so it's not happen at all. So how we maintain that state in the application, because one transaction is spanning across multiple services. And all, if you remember, like if you want to implement a true microservice-based architecture, in that every service should have its own database. So in unlike the previous application which you saw, in that we had one central database, but here every microservice has its database, and one transaction, that is basically a book my holiday transaction, is happening across, like spans across all the applications. So for example, you if you are doing one transaction, then suppose hotel booking is successful and database for that is updated. But what happens in case the flight booking is failed, right? So it's a challenge because the state of database for the hotel booking has changed, but the flight booking has not happened. So as per our business scenario, it is a failed transaction. So we cannot, we need to revert data in the hotel booking database, because that will make sure that we revert back to the previous state which was before we started this transaction. So this is how this is a very challenges which we face when we use the distributed transactions, right? To overcome these challenges, we use or we basically employ the two-phase commit in microservices based architecture, when where services are like distributed and have their own databases. So this in this basically what happens, that we have a coordinator that performs like two steps. One is the prepare phase, and second is the commit phase. So in the prepare phase, it asks every service, because like every like in one transaction, one transaction spans across multiple services, right? So either all services need to be successful. If any of service is not successful, then we have to revert back to the previous state of databases, right? For each service. So, for example, if you are doing any transaction, and then this coordinator will ask every service whether they are ready to commit, and once it get acknowledgement from the e-service, it will give a go-ahead signal to commit the actual data. And then once, for example, if every service send back a success response back to the coordinator, then that transaction is successful and it is a happy path. But for example, if any one of the service fails because of any issue, maybe any code issue or any network issue, then it will not send the acknowledgement back to the coordinator. So in that case, the coordinator will ask each and every service to revert back to the previous state of their databases. So with this with this architecture, or with this solution, we make sure that all these services which are part of one transaction logically from business point of view, they should commit together or not commit at all. So this is like a very good way to make sure that we remain consistent with our transactions. But there are some problems with two-phase commit. The main issue is that we have a central piece over there. There's a coordinator node that is basically kind of a single point of failure, because all the communication which is happening back and forth is happening with that coordinator. And in case it itself goes down, then who is responsible for the transaction? So it's a problem in this type of solution. Then second problem is that it is very slow, because suppose we have 10 services which are part of one transaction, and one service is very slow, then the speed of your transaction is determined by the slowest service, right? So it sometimes it degrades the performance of your application, because it is bound by the slowest service. Then another issue is that there is lot of chattiness, because lot of messages are going back and forth. So a lot of chattiness happening in your application, and like it's also add to the latency and performance issues. Then suppose because in Microsoft architecture we can deploy the multiple tech stack, multiple databases. So in case if any of your services is using the NoSQL databases, then you cannot use two-phase commit because two-phase commit does not support NoSQL databases. So these are the various challenges for the two-phase commit. So the solution here is to use the Saga pattern. So till now, what we have discussed, I have set the context like why we need Saga pattern that we'll see later. But at least we know that okay, the challenges right now which we have in the microservice architecture and how we are trying to solve them by the two-phase commit. Still, we have more issues to solve, right? So for this video, that's it because I don't want to make it a longer video. So in my second part, I will cover the Saga pattern. What is Saga? And how the Saga flow works, and also the various type of patterns like the choreography pattern and the orchestration pattern. So yeah, please see my second video if you want to learn the complete thing. So for now, that's it. Thank you very much for watching, and see you next time. Please leave comments or questions, and please subscribe my channel if you like my videos. Thank you.